Hey there, CS210 students. So in this recording, we're going to take care of Chapter 9. And in this chapter, we are going to learn about inheritance, polymorphism, some pretty powerful object-oriented programming concepts. So at this point, you should be familiar with creating classes in C++, being able to encapsulate information about something, and then providing getters to get access to the information, constructors, methods that might manipulate the data. We should be very familiar with creating the classes at this point. The idea here is we want to take functionality that's common to things, place it in one class that can be reused by other classes of the same type. So real quick example right here, we have just some kind of generic item that might be in a store. And for a generic item, it's going to have an item name, it's going to have a quantity, we're going to have the ability to set the name, set the quantity. Remember, I would say never do that. I would say do it in the constructor. We should have a get name, a get quantity. We have a print item method. I'm okay with that. But the generic item has a name and a quantity. Well, what if we have a produce item? So if we have a produce item, we still want the item name, item quantity, but why duplicate the efforts of having the exact same code, copied and pasted? What we should do is extend the functionality of this generic item and add what the derived class needs. So a produce item definitely has an expiration date. So we'd want to have that as a field, and then we'd want to have methods to get it and potentially set it. So remember, the idea of inheritance here is we want to take what our base class has, share it with the derived classes. So again, that's the idea of inheritance. Terms that you're going to hear, derived class or a subclass, base class or superclass. So keep in mind the generic item here, this is our base class. It contains the name and quantity, and then everything that's going to extend from it, that's going to be deriving from it, that is a subclass of it, is going to then have those features. So here's the definition of the generic item. Here's the definition of the produce item that's inheriting from generic item. So here's the syntax for it. We say produce item, colon, public generic item. So this is public class. We are going to create a public class from this as well. So we can then have public set expiration, get expiration, and then private member variables for expiration date. Okay. Now, oh, by the way, one thing that makes this a little tricky here is because we made this item name and item quantity private in the base class, I have no access to it in this derived class here. Now, I can get access to the methods, okay? When I create an instance of a produce item, it's going to have set name and set quantity. It's going to have set expiration, get expiration. But I do not have any way of touching the item name and item quantity fields in the produce item, okay? So we'll talk about that here shortly of how we handle that, so that way we can see these variables if we want to in all of the derived classes. So inheritance, there's lots of different ways of having inheritance. So keep in mind, they started out with having a generic item that could extend a produce item. Just think, we could have fruit items, we could have dairy items. You know, they're going to have different implementations based on their needs. Instead of having produce items, we could have a book item. And just think about this. Every book has a name and a quantity, right? Well, we could even extend book item. It could be a textbook. It could be an audiobook. So we could create inheritance trees that all end up with generic item at the top, where the common functionality is defined right here. And so then they go through, again, another concrete example here. We have a business. It has name and address. A restaurant is a business. So it would also have a name and an address. And again, unfortunately, the way that this code is initially set up, this restaurant doesn't know anything about its name and address down here. Okay. When I do get description, I can get the name and address. That's going to be a method that's available to any instance of a restaurant, but I can't manipulate it down here. So let's talk about that. How do I know what I have access to and what I don't have access to? So because restaurant is a business, it's going to have a set name, a set address, get description, set rating, get rating methods. These are all publicly defined. So they're all going to be available to the restaurant. So restaurant, favorite place, I can do set name, set address, set rating. Those are all available to me. And remember, set name and set address are actually defined in the business class. The business object here, some business, keep this in mind. It is only going to have access to set name and set address. A business is not extending restaurant. So you do not have any of this stuff if you're thinking that you are looking for those from a business. They don't have it. Always keep in mind what your data types are. This is a business, so it gets access to this information. A restaurant has this information as well as the business information. So we get these other three pieces right there, okay? So when you're working and if you hit the dot operator and if you don't see what you're looking for, then that means the access modifier is not sufficient for you to see that, or it doesn't have that, okay? All right, so access, I just kind of alluded to a bunch of that. So the business has, again, name and address. And if we were to come down here and in the restaurant class that extends business, if we were to try to display name and address, we are going to get errors in this display restaurant. We might get, it might tell us that name is private in a good compiler. So how do we provide access to these variables in the derived class? Well, we have different types of access. We can use the protected access, which gives us access to the variable within the business class, but then also any class that extends it. So down here, when I say restaurant extends business, I have access to name. So now I have access to the name variable inside the class. That's going to be just okay. But address is still private. We don't have access to it down here. So this is going to be a compilation error. So it would make sense that the restaurant should know its own address. That should probably also be under protected. So the rules are pretty simple. Public, anybody and everybody can have access to this. That should only be done for methods. Private, it's only accessible to the class itself. So in this case, if you want every business to have access to its address, we don't want to make that private. We want to use protected because it's available to itself as well as the derived classes. So again, nice little chart summing all that up. Next thing we want to talk about is in your base class, you may have a method that you want to implement differently in the derived class. So we might have a method called getDescription, and in the base class, we're just going to provide the name and address. But in the restaurant, not only do we want to provide the name and address, but we also want to get the rating information concatenated as well. So we can use the exact same method signature. So string get description const, which means we can't change anything in there. Same definition, we're just going to override what the functionality is. So overriding means we keep the same signature, we're going to override, we're going to change what the functionality does. So again, nice use case. We'll talk a little bit more when we get into some abstract details. This should really be an abstract method where we are forced to implement what the get description looks like. So keep in mind this, overriding, you are always maintaining the signature. Excuse me, so we are maintaining the signature right there. Overloading means we're going to have a function with the same name, but we're going to have a different parameter type, different number of parameters, and so forth. So it's not necessarily the same function. It's just going to have different information possibly added to it. Now, one thing that you have to keep in mind is you can call a base class function that's defined. So remember, our restaurant class has a dependence on the business class. It's a child class. And we could actually call the business class's get description and then concatenate that with the rating. So keep in mind the definition up there of get description has the name and address right there. And look, we duplicated that code in the derived class. So we can call the base class method. We just have to use the name of the class, the scope resolution operator, and then call the method. Okay, so in object-oriented programming, polymorphism, or the ability for an object to be represented several different ways, is very powerful. And in C++, we have two different ways of having polymorphism. One is at compile time. So when the compiler creates the executable, it determines which functions to call. But there's also runtime polymorphism, where the compiler is not able to determine which function to call, so it has to do it while the program is running. So they give us a couple examples here. So we have methods drive to. So we have two different methods here. One takes a string, one takes a restaurant. And so when we call this method down here in compile time, this would say, all right, drive to, this is taking a string, so I would have to use this method right here. In runtime polymorphism, we have this method right here, and this is going to call the business's get description method. So this is going to be handled at runtime, not at compile time. So a little bit of nuance there. The big idea that I want you to understand about polymorphism goes with having virtual functions. So runtime polymorphism only works when we've overridden a function in a base class and it's been defined using the virtual keyword. What that virtual keyword means is I want my class, I want the business class to have a method, and then the other classes can then override it in runtime. So this ensures, so I define the method using the virtual keyword. I define the overridden implementation using the override keyword. This guarantees that the runtime environment is going to call the proper method when needed. So we'll also see here in a second. So that's one advantage. We have to have this in order for runtime polymorphism to work. And then the second thing you're going to see is this is going to relate to abstract classes. So down here, we could have what's called a pure virtual function, where again, we have the virtual keyword. And then you can see that when the method is defined in the class, we set it equal to 0. So this tells the compiler that this is a virtual method, that every instance, every derived class is going to have this implementation, but they have to define the method themselves. So let's see how that works. So I've got business right here is defining a virtual function. So there is no implementation. Whoever extends this class will have to provide an implementation of get hours. And so if I scroll down, they have another example here. No, this is a participation activity. They'll have it in, sorry, it'll be in the next section. Let's go to 9.6. So in 9.6, they formalize the definition of abstract classes. So leaving off, we had a function, we defined it virtual, we assigned it equal to 0. So whoever extends this class has to implement this functionality. And so they do that with a class called shape. They're going to provide a virtual method called compute area. So every class that extends shape is going to have a compute area method, but we have to implement the functionality. So if I scroll down here, here's the shape class, and circle extends shape. They define what compute area is for a circle. So circle is different from rectangle. Again, both of these have to define the compute area method because it's defined in the base class as a pure virtual function. Okay, so very powerful idea. If you know that you have some method that you want every object to have, but you don't know how it's going to be defined, then you define it using a pure virtual function. And then, oh, by the way, uh, this could have the override keyword not required. Very useful. I would recommend to do that so that way people can see that, oh, hey, I overrode a method from the shape class. Okay, another big idea in this section is that we can create what's called an abstract class, which is just a template for the information we want to encapsulate. So think about it this way. We have a shape. It has some position, but that's it. I can get the position, I can set the position, I can move it relative, but there is no such thing as a shape. They're either circles, rectangles, we could create squares, triangles, parallelograms, all the actual shapes, but when I create this with the virtual methods here, this makes it an abstract class. I cannot instantiate something that has a pure virtual function. So if I were to try to instantiate a new shape, I'm going to get an error. I can't do that when this compiles. And again, the shape idea is that we want the ability to have a position for the shape, and we want it to have a compute area method. So all of the implementations of shape, circles, rectangles, and so forth, have that, and then we can actually initialize those values. Okay, last thing in terms of object-oriented programming, the concept of inheritance sometimes gets confused with the idea of composition. Composition is the idea of composing an object of other fields, other objects. Inheritance is the idea that it's going to extend and be a child of the base class. So think of it this way. Child info has a first name, has a birth date, has a school name. So these are fields of the class. If I scroll down, let's say we want to strip out the first name and birth date to a separate class. Well, is child info person info? Is it a person info? Yes, absolutely, because it's going to have the first name and birth date. So very powerful concept. Keep in mind the difference between the two. All right, I know that's a ton of information. Ultimately, if you want to become a good software developer, you need to be able to write inheritance trees that are very effective. So be sure to work through the examples in here. Don't just click and point. Go through and really dig into learning how to create inheritance.